Alright, so for the third example I've picked one that's a log problem, and this is also a chain rule problem, and we've got tan on the inside there as well. And if you haven't had a look at the proof for the derivative of tan, it just uses the quotient rule, and it's pretty cool to show that the derivative of tan is sec squared x. So with logs, one of the things that we probably don't talk about often enough is that if I differentiate a log of some other function, then that's a bit complicated, but it's just basically saying find the derivative of a log that has another function inside the absolute value. Then the derivative of this is actually pretty easy to find. I simply differentiate the inside part of the log divided by whatever the inside part was. So if we look at this problem, all I need to do to differentiate log of tan of a half x is I find the derivative of tan of a half x on the top line divided by tan of a half x on the bottom line. I've got an extra bracket in there. There we go. So all I need to do to actually differentiate this problem is find the derivative of tan to a half x. So let's say if u equals tan to the half x, I can go straight to my formula sheet and say that the answer is a half sec squared of a half x, and then put that together with my expression over here, and I find out the final dy dx, I'm not doing all the formal notation this time, is a half sec squared of a half x divided by tan of a half x. Now that's still pretty messy, and we can actually tidy this up a lot with some algebra. So the first thing I'm going to do is drop that 2 to the bottom line, and I get sec squared of a half x divided by tan of a half x. And remembering that sec is cos, so that top line is actually 1 over cos squared a half x, and the bottom line, which is tan, is sine x over cos x. Flip and multiply. Oh, I lost my 2 here as well. That should have been a 2 down the bottom. So that 2 has to go down the bottom. I'm going to put it with the top line. So flip and multiply, I get 1 over cos squared a half x times by cos x over 2 sine x, and they're a half, and that's a half. Everything was a half x. I've lost my halves in here, so that's a half x, and then one of these coses cancels out with that one, and I'm left with 1 over 2 sine x cos x. And hopefully you recognise the double angle formula there. So it becomes 1 over sine, I've lost my halves again. Let's go back a step. This is 2 sine a half x cos of a half x. You can see how quickly you can lose track in all the algebra. As I mentioned, that's the double angle formula. So it's sine of 2 times a half x, which is just 1 over sine x, which is a really, really neat finish. Cosec x. So that's kind of nice if you wanted to do the integral of cosec x, we can jump straight back to our original expression, which was log e of tan of a half x. But that is coming up in our next topic, so don't worry about that last line.